Hello and welcome. You're on BharatShakti.in. I'm Nitin Gokhale. And with me are two eminent panelists, and we are discussing the development and the progress of light combat aircraft Tejas, indigenous fighter aircraft meant for the Indian Air Force to begin with, and of course for exports as the development takes place. This is, of course, in the context of the government deciding last week to order for the Indian Air Force the Tejas Mark 1A for 83 of them, in fact, for inducting into the Indian Air Force. Welcome both of you again, Commodore Balaji and R.K. Radhakrishnan. We've had the discussion about the background in which LCA Tejas was conceptualized and how one of the landmark events of it going for the first time abroad was brought about and how it panned out in January 2016. But let me come to you, Commodore Balaji, about the strengths of LCA Tejas and the kind of value addition it is going to bring to India in terms of Make in India and defense.
Thank you very much again, Nitin, for this opportunity to share my thoughts. I would put it as a kind of a return on investment type of a scenario. And in my earlier thing, I had mentioned that along with Tejas, we were also building in technologies, right? And so it's not only the aircraft which took off, it's also the technologies which took off along with the program. Right. So if you look at it, what is the kind of investment that the government has made over these, even if we take the seed money from 83 onwards over this entire period, has been of the order of 9 to 10,000 crores total, has been the total design and development amount that has been done. Now, it's not only to build these aircraft, it is also not for just the Tejas, it is also for the LCA Navy, the future programs, etc. also. So that is a total investment so far that has been done. But along with this investment, there has also been a build-up of the various tooling, jigs, fixtures, test equipment, everything that have been required in not only ADA, in HAL, in various public sector undertakings, in private sector undertakings. Everything has been funded through this particular program, right? R&D labs, if there are research work going on in academia, all this has been part of this funding. Also, this fund catered for the build of the infrastructure at HAL for the limited series production of 8 aircraft per year, which is what has actually been used for the subsequent thing. So this is the total investment that has been made. Now, let's look at the returns of this investment. Now, first and foremost, I think is HR capital. After HF24, practically it was, very little aerospace work has gone on for over 2 decades in the country. It was purely something like a license build of aircraft which is going on, right? So we had to build up the HR capital, and that I think is one of the key elements of building up the HR capital, which is an intangible asset for the return, because you can't quantify that particular thing. But this HR capital actually has built up the strength in our structural design, in terms of our analysis, in terms of simulation, in terms of your testing, in terms of avionics, the flight controls, various mechanical systems like what Radha brought out about AMAGB, which was done by CVRD, is a mechanical system item like this. And like the heat exchangers which are done at Bharat Heavy Plates and Vessels. Who imagined that a huge Bharat Heavy Plates and Vessels in Visakhapatnam, which builds huge heat exchangers, can build miniature heat exchangers for an aircraft? But yes, there was a kind of incubation done. I mean, those terms were not existing in those times. What we talk of startup, incubation, etc., is actually an incubation which was done at that stage. Then software development, etc., and so on. So HR capital build-up for all this is one significant element. The other, of course, as I mentioned, has been the infrastructure that has been built up for various assembly and testing of the aircraft. Now, this infrastructure will automatically be usable for future programs, which we can comfortably use, so that we don't have to invest our time and effort in that. Maybe small upgradation that you have to do, that is there. The third major element that ADA was able to bring together was a robust network of partners from the academia, public and private sector industries. In fact, there are over 300 major and minor partners in India itself, which are thing, and every corner of the country has been practically covered, right? So that is another thing. Now let's look at the order book from the
Yes.
cost perspective. Investment is about 9 to 10,000 crores. The order book for 123 aircraft, I'm saying this 48,000 crores is for the 183 aircraft. And if you put together, yeah, the IOC and FOC, it's of the
Yes.
order of around 70,000 crores. That means it's about 7 to 8 times that the money has been flowed back into the country. Now, this is only for a acquisition cost. Now,
Yes.
if you look at support cost over the lifetime of this aircraft, it's
Over
another
the
one and a
years.
half to 2 times, right?
Mm.
So that's the kind of return that we are getting within this country. So now coming to the point that you mentioned about the robust supply chain. Now, what has
Yes.
this done? Now, when we had an order of 20 aircraft plus 20 aircraft, HAL was a little hesitant about developing a robust supply chain because they were not very sure whether they'll have a large enough order, because it only makes sense to offload things if you have a sizable number. That is when actually the trigger of 2016 with Mr. Parikar had given the DAC approval, probably charged up HAL to think that they can also go for an offloading. And that is when this concept of tier 1, which are basically making major modules, tier 2 which makes sub modules, and tier 3 which makes parts, were kind of brought in. So if you look at Tejas, for example, we have major tier 1 partners which have been nurtured now. For example, the entire fuselage assembly is built, split into 3 parts: the front,
Right.
the center, and the rear fuselage. So the front fuselage is being done at Dynamatics, the private company in Bangalore.
Right.
The center fuselage is done at VEM Technologies in Hyderabad. The rear
Mm.
fuselage is a company called Alpha Tokal in Bangalore. The wings will be done at Larsen and Toubro at Coimbatore. The fin and rudder are done at Tata Advanced Materials Limited at Bangalore. Now, these are major assemblies which are coming from the private sector. So HAL now becomes a lead integrator, which is what like major aircraft houses like Boeing or Lockheed Martin does. They are a lead
Correct.
integrator, and then they finally test out and fly the aircraft out. Now, these tier 1 chaps won't do everything themselves. There will be
Correct.
sub-assemblies in the front fuselage, which they will go to tier 2 vendors. And
Yeah.
tier 2 vendors will go to tier 3 part manufacturers. So effectively what happened is this program has enabled this culture of tiered manufacturing process, which has been set in. The
This is
other
yes.
other
Go ahead.
important positive other important positive that has come, as I mentioned earlier also, is the software. There are about 38 computers in this aircraft, between flight controls as well as avionics or mission computers. 100% of this software is within the country. That means we have the intelligence within the country, the software control is the country, and believe you me, that the any vendor abroad will twist you only on the software,
So this is the
and
protection that the LCA has. This is the protection
yeah,
the LCA has in that.
and she has. And this thing, all these actually have built up a complete ecosystem for future programs, in addition to actually building up these aircraft. I
I'm
thought in a
glad.
nutshell, this is what it is.
Yes, in fact, it's a very elaborate, and I'm glad you gave this complete rundown on how this ecosystem has been built, even for the initial orders. But RK, when you were the man in charge of industry interaction and interface,
Right.
did you feel this hunger amongst MSMEs and smaller tier two or tier three suppliers to do something for Indian programs, Indian weapons platforms? What has been your experience, and do you think this was going to give a further boost to what is now called Atmanirbharta in make in, or in defense, or make in India in defense? What's your sense?
Absolutely. It's right. I was a director industry interface. I was engaged. I was involved with a number of industries across various programs. LCA is a one of the largest program where we brought in number of industries. One more point which I want to add to what Commodore Balaji mentioned about the return of investment. One is what you are doing, a direct return of investment on the amount of the orders you have got. The implicit thing, the nation as a country, as the industries in India actually got to know what is airworthiness certification is all about, because Always it has been with the under HAL. Everything was doing under one roof, under licensed production. You are not allowed to use, the technology was not going to the private sector industries. LCA program, actually, that number of equipment systems are all realized the private sector participation. Designing is one, and then make it certify for flightworthiness is something totally different. It's an animal. The kind of effort required to get the certification. Then the industries which are involved actually got to know how to get this airworthiness certification. But number of almost every one of the industry who has supported the LCA program, they are also now exporters. They have become now the country. A lot of avionics is getting exported to various other programs. They all now able to get the benefit of that, and then they could even export also. So
Right.
definitely that the MSME is played a key role, and they had a major benefit because through these programs like this help them to understand what is the military requirements are, and we are able to handhold them. And today that the Atmanirbhar Bharat, actually the foundations were done by these large programs. When the production orders, because earlier we did all these prototypes, nobody was ready to provide us the orders. This government came and then started giving the orders. If you do
Right.
something, unless the orders are not there, nobody is going to be, you can do
Industry.
for one or two. Yeah, that's what happened. The sea change happened because people see that one, like there is a large opportunity for industries to contribute to the defense thing. That has definitely happened, and these large programs actually set an example for those things.
Right. Commodore Balaji was someone who's been in the Navy, and then, of course, also someone who was the director of ADA, or the ADA. You also worked on the naval version of the LCA. Give us some sense of what that meant. What was the different challenge you mentioned in the previous discussion, that it's a completely different animal. You use the word or the term different animal. If you can tell us what's so different from LCA Mark Tejas Mark 1A to, say, LCA naval version.
Uh, when we started the program in 2003, we'd anticipated that we'll convert the Air Force version to a naval version. I think that is where we started with. And we said, we identified certain areas. We said roughly about 15 to 20% are the not so common elements. That was what was identified in the project definition when we went to the cabinet for the approval. And these were identified in terms of the landing gear, which was supposed to be different because you need to operate from an aircraft carrier, and the arrestor hook that was required. Also, we
Right.
need to actually reduce our approach speed, so therefore a new control surface had to be brought in, and structural design. So this was something like what we had anticipated, but this was in the concept stage. But when we started getting into detailed design, now the operating environment which the naval version has is entirely different. For example, you have a luxury of a large runway for a land-based aircraft, but on a ship you just have 200 meters for takeoff, right? So you just actually get thrown out of the ship. So it's
Yes.
launch. It's never called takeoff. It's called a launch from a ship.
Right.
Now,
Yeah.
when you have to land back, you never land. You recover because you just have to with the arrestor hook on engaging the wire on a carrier, and so you recover an aircraft, and you just have 90 meters for arrestment. So when you have to launch, you in 200 meters, you are still not fully airborne or wing-borne, so to say. You're
Yes.
still in a ballistic trajectory. Now that is where the control law, which we had gained significant strengths in the country, came into picture. And how did we work the control law so that we can handle this aircraft, where after it gets thrown off the ski jump, the aircraft will start sinking. But then it is because of that sink that enables it to gain some forward speed. So it's a trade-off between potential and kinetic energy, and then you keep going forward, and then you take off. Now recovery has because of that 90 meters of recovery, you have a huge amount of load coming in. It's 4.5 g that you get on the recovery.
When
So
you come, yeah.
therefore the hook load has to be reacted within the structure. So the structural design was a massive challenge. Now
Hmm.
if you have to actually go through, like Radha brought out about certification, now the certification agencies will not allow you to directly go to an aircraft carrier. So
Yes.
we said that let us recreate an aircraft carrier on shore. So that's where
Okay.
we built the shore-based test facility at Goa. So
Yes.
as part of this program, so in fact, that entire facility was also part of the naval LCA program cost itself. Was built up there, where we replicated the aircraft carrier with a ski jump, the arresting gear, and everything, and also built up a full-fledged telemetry facility there. So that was another thing. Now, on an aircraft carrier, when you're coming, if you have to reduce your approach speed, you need something different, right? So we built a new control surface called leading edge vortex control, or LEVCON, in the
Mm.
wing forward region. So that was a new control surface, and we had to work on that thing. Now, when you come for a carrier approach, you cannot see from the Air Force version, right? Because
Yes.
you are at a fairly high angle of attack. So how do you
Sure.
do that? So we had to actually droop the nose down on the front fuselage by about 4 degrees, so that the
Oh,
pilot can actually see the aircraft carrier. So that
okay.
was another change. So as the design progressed, we had to actually go through all this. And therefore,
Mm.
probably that additional couple of years that we took from whatever we promised to the CCS was because of these challenges that we kind of went through. And, you know, uh, to prove to the certification agency, whether the structural loads that the aircraft is ready to face, is it going to be actually uh, actually valid? How do you prove that? So we
Yeah.
built another complete aircraft, full-fledged. We built a full-fledged static test facility in Bangalore, in HAL, and then we imposed structural loads 1.5 times to what it would face on the carrier, and then instrumented it extensively, validated
Mhm.
all our simulation results before we allowed it to first even get to SBTF.
Okay.
And once we were able to correlate that what we got in SBTF matches with whatever correlation we had on the ground test, we were confident that yes, we are on the right track. And then in January of 2020, the first arrested recovery on Vikramaditya was done, and then the launch the very next day on the 12th of January. And so exactly about a year back that was happened. And believe you me, within 5 days, they have done 18 recoveries and launches on Vikramaditya. And, uh, this brought a kind of a closure to a dream of building a
Naval
indigenous
work.
tech-based fighter aircraft in the country, where I
I'm
was
so glad.
probably able to take her right from paper to flight, so to say, from the
Absolutely.
government approval till flight.
Congratulations on that fantastic achievements, I must say, because not too many people know about this except for the professionals who are involved in this, or the people who are in the Navy. But RK, when you look at this entire development and progress of LCA since, let's say, not in 1983 but 1993, as has been clarified by Commodore Balaji, do you think the Indian industry, the Indian MSME, is now ready for the next stage of evolution of defense and aerospace in India? Because the AMC, the AMCA, is likely to come in now. As far as the Air Force is concerned, it wants the advanced medium combat aircraft, and of course, go ahead with development of an engine and other facilities that are needed in this aircraft. What is your sense? Because you have interacted with the industry so much.
Right, absolutely. Actually, that no, these programs are given that the both the skill sets which are required for the MSMEs to take up a more challenging work. And second, the DRDO also established a lot of infrastructures which are otherwise not possible for the MSMEs to build those things. All those you are saying, all these fundamental requirements which are required to take up a more challenging task already been done. So this will come in handy for the MSMEs, and they are already now all these most of the MSMEs who participate in that one are fully aware of what it means to develop a system for an aircraft, a fighter aircraft. So they are fully equipped, they're trained, and more people are now coming with getting into this one because after seeing the success and the numbers are available. So this is something which people can get into for the long-term business opportunity, because any industry who is looking at it is what you welcome the challenge, the initial challenge, but also they are looking for, is there a business, is there worth investing their time so that there is some they can get some benefit out of that. So these orders have proved to them India is this is India. We can actually they can get the benefit of putting their worth into this field, and all those stepping, all these building blocks are there. So I don't think that one it is only it's an upward trajectory for all the MSMEs now. More industry will get into that one, and more challenging because these are all most challenging work they have taken up. So it will also come and help, like a lot of other acquisitions are taking place. India is also going to become like a manufacturing hub for not only for Indian equipments, but also for the export market for the OEMs. So that
Yes.
is going to be a big boost for the years to come. So that's I'm excited about it.
Excellent. Commodore Balaji, last word to you. With this development and a large order now having been placed on the HAL, do you think India is now poised to become one of the few countries in the world to have a long-term manufacturing facilities and manufacturing ecosystem for fighter aircraft to be exported, not to be just used in the Indian Air Force, but also to be exported to other countries? And of course have more and more development taking place for the future for the aerospace and defense industry as well as for military aviation.
Absolutely. I think you've brought in the correct point. If I may actually sum up in a kind of a thing, that always the country has had a mood of can we. We were always poised with that question. I think that has changed to we can.
Absolutely.
So that sense has changed, and also the sense has changed from skepticism to optimism. And
That's right.
with this, I think we are poised for great things in the future. We have the what Radha brought out. We have the building blocks available. We have the infrastructure available. We have the human resource capital available, which we need to nurture. And incidentally, I am working because of the government of Karnataka after my retirement for skill enhancement into the aerospace sector, where I'm mentoring students to come to the aerospace domain, because HR capital we need to nurture and build up, and that's the very important element. And I'm sure this private sector participation will come in a big way with the ecosystem that is coming in. And I believe that the thought process that the government has is that for programs like the AMCA, etc., if they can involve the industry along with the development team right from the day one, it will probably help. I think that is where we should focus on, so that we take them along rather than give them some work later on. They can be partners with you.
Yes,
That's
right.
the mood that is there.
So clearly, the experience and the what, after all, what is experience? Experience is the name people give to their mistakes. So I
Yeah.
don't want to say that they were mistakes, but that was a learning experience, learning process. Whatever learning process has happened in the LCA program right from the beginning has now can be dovetailed into the AMCA program and going forward. And perhaps India is, as I said, poised to become one of the major manufacturing hubs for military aircraft, and it's a boost to countries around India and to friendly countries that India has good relations with. On that note, let me thank both of you once again, and for that fantastic narration and the background and the kind of work that has gone into this. I'm sure people will benefit, those who are looking to come into aerospace and defense industry, students, engineers, academics, all of them will benefit from your insights. And for that, I thank both of you for sparing your time.
Thank you very
Thank you
much
again.
for having us over on the show.